All right, we're going to look at powers of 10. So our I can is I can explain patterns in the number of zeros and use whole number exponents. Okay, a little bit of vocabulary to get us started. Let's look at the number 10. But this 10 is not by itself. It's going to have a little raised number to the right-hand side. This little raised number has a special name. It's called an exponent. This bottom number is called the base. Let's do one more example of how this looks, then we'll talk about what those numbers mean. Say 8 to the second power. The bottom number is the base, and the little raised number is the exponent. Okay, so the base and the exponent. The exponent tells the base how many times it's going to be multiplied by itself. Let's use the 10 as an example since we're doing powers of 10. Let's do 10 to the first power, 10 to the second power, 10 to the third power, and we'll end up with 10 to the fourth power. Okay, so if we were to expand out and write each one as a product of tens, so remember the exponent tells us how many times we're multiplying the base by itself. So if I just have 1, I just have 110. What about 10 to the second power? That's 2, so I'll have 1 times 2 tens. 10 to the third power is saying I'm going to multiply 10 by itself. 1, 2, 3 times. 10 to the fourth power is saying I'm going to multiply 10 by itself 4 times. Here's 1. Here's 2. Here's 3. And here's 4. So you can see the pattern of tens. All right, the last thing we're going to look at is the standard notation, how you'd write this number in standard form. So 10 to the first power and 10 is simply just 10. Pretty simple. 10 to the second power is 10 times 10, or 10 times 10 is equal to 100. 10 to the third power, or 10 times 10 times 10 is equal to 1,000. And our final one is 10 to the fourth power, which is equal to 10 times 10 times 10 times 10, which is 10,000. The pattern is that for every exponent that has a base of 10 also tells you how many zeros are in the standard notation, or how many tens there are. So 10 to the second power, 2 tens, 2 zeros. 10 to the third power, 3 tens, 3 zeros. 10 to the fourth power, 4 tens, 4 zeros. Now, how does this come into play when you multiply or divide by powers of 10? Let's start with one example, 9 tenths times 10 to the third power. Okay, first thing first, let's go ahead and look at this 10 to the third power and rewrite it in standard form. So 10 to the third power in standard form is 1,000. I'm going to bring everything else down. 9 tenths times 1,000. So I'm multiplying by a whole number. I'm going to increase this decimal, or increase the first number. Just some steps to help you get warmed up is looking at the operational symbol. It's multiplication by a whole number, so you're moving the decimal to the right. Multiplication right. How many times? The trick is to look at the zeros, but the reason you're moving the decimal 3 place values over is because really 10 to the third power is 10 times 10 times 10. Each 10 will tell you to move 1 place value over for each 10. So there's 3. 3 place values. 1, 2, 3. I moved it once, that's all fine and dandy, but the second 2 times, you're missing numbers, so you have to hold the place value with zeros. So it's 9, 0, 0. 900. Remember, 900 is equal to just saying 900 with the decimal. Those are the same things. We assume it's a whole number if there's no number or no decimal to the right-hand side or anywhere in the number. All right, let's do one division. This time we use 2 digits, so 6 2/10 divided by 10 to the second power. Okay, again, looking at the exponent first, so the power of 10. So 10 to the second power in standard notation is just simply going to be 100 because it's 10 times 10. Bring everything else down. I'm dividing by a whole number. I'm going to decrease the value in the first number and moving the decimal to the left. 2 times 10 times 10, that's 2 tens. The trick is to count the zeros. Here's my decimal. 1, 2. Again, there's nothing here. So when I write out my answer, I have to hold the place value with a 0. There's my 0. And then rewrite the rest of the digits. 63 thousandths. The last thing is to always look at the answer and to make sure it makes sense. So 9/10 times 1,000 is equal to 900. That makes sense. You're increasing its value. 6 2/10 divided by 100, you're decreasing its value, is 62 thousandths, right? That makes sense as well. All right, that's all for powers of 10.